Yo, Chuck.
All right, this video is going to be on Leetcode 238, product of array except self. So we're given an array of numbers, and basically we want to find the product of every number except for the current index we're on. So when the current index is 0, we are going to want to find the product of these three numbers and then update our index to that number. So 2 times 3 times 4 is 24. Now we increase our index to 1 and we want to find the product of all those numbers. So 1 times 3 times 4 is 12. And then repeating the process, we increment our index to 2. And now we want to find the product of every number except the number on index 2. So we would take 1 times 2 times 4, which is 8. And then finally, we have index 4, or index 3 rather, which is the product of 1 times 2 times 3, which is 6. So this is our answer. So the problem's pretty straightforward, and you might be tempted to do like a nested for loop of some kind. But the problem with that is the algorithm requires an O of n runtime, and if you're nesting for loops, it's probably going to be O of n squared runtime, which is not what they want. And oh yeah, also you can't use the division operator. So that's kind of a little constraint that makes it a little bit harder. So what we're going to do is take this 1, 2, 3, 4 and convert it to 24, 12, 8, and 6. How are we going to do that to satisfy the O of n runtime requirement? Well, what we're going to do is just create a left and a right array, and we're going to basically instantiate them with ones across the board. Notice they're the same length as nums, and basically all we're going to do is find the product to the left and to the right of that current num. All right, so initially we start at index 0. We're actually going to start our I variable at 1, at index 1. So it's going to be equal to 1 at first. And then we're going to compare that. So we're going to set left at I equal to left at I minus 1 times nums at I minus 1. And this is basically going to get all the values of the numbers to the left of the specific index we're at. And we're going to keep track of that product. You'll see what I mean as we go through. So first, let's update left at I to equal left at I minus 1 times nums at I minus 1. Left at I minus 1 is 1, and so is nums at I minus 1. That is also 1. So 1 times 1 equals to 1. So we're going to set left at I equal to 1. So we increment I, nothing has changed as you can see, but now we're going to also update left at I to left at I minus 1 times nums at I minus 1. So 1 times 2 is now going to be 2. So I'm going to update this value to 2. Notice again how I'm keeping track of the product of all the numbers to the left of the specific index I'm at. Because I is equal to 2, I'm at this specific point. This is going to be equal to 2 as far as the left product, because 1 times 2 is 2. That's why I'm updating this value to 2. So we're going to move on now. We're going to increment I. I is going to be equal to 3, and we're going to take left at I equals to left at I minus 1, which is 2, times nums at I minus 1, which is 3. Well, 2 times 3 is 6, so we can update this final value of I to 6, or left at I should say. And now you have the product of all the numbers to the left of that index. This makes sense because if I was at index 3, that would be number 4, and now I'm going to multiply 3 times 2 times 1, 6. So that's why I have the product of the numbers to the left is 6. Same thing, we're going to now transfer over to the right. We're going to switch it up a bit and do it inverse now because we want to find the value to the right of the current index I. But it's basically the same concept. So right at I, at index I, is going to equal right at I plus 1, which is 1, times nums at I plus 1, which is 4. So we can update this value as to 4 because 4 times 1 is 4, right? And now we're going to decrement I, and same concept. Right at index I equals right at I plus 1, which is 4, times nums at I plus 1, which is 3. 3 times 4 is 12. Therefore, we can update right at index I to 12. And this makes sense again because if I was to come over to nums at I, right, and then I need to take the product of everything to the right of that, well, 3 times 4 is 12. So that's why this is 12. One more decrement of I. And here we are. Now let's do right at index I equals right at I plus 1, which is 12, times nums at I plus 1, which is 2. 2 times 12 is 24, therefore we can update 24. Okay, so you can see how, because we're finding the product of these elements, it's kind of concurrent, and we can basically capture the value or the product of everything to the right and everything to the left pretty easily. So now we're pretty much done with nums, and I can make a new array. I can fill it full of junk data, doesn't matter. I'm basically just going to compare left and right values at that index, or left and right product values of that index, and then multiply them now. So I'm going to make a new array called result. It doesn't matter what these values are in here. I'm just using 1, 2, 3, 4 as filler data. But basically, I'm going to say result at index I equals right at I times left at I. Recall that we want to find the product of everything other than the current index. So this is what the left at I times right at I is going to accomplish. So the first one, we have 1 times 24. Well, that's going to equal 24. So we can update result at I to be equal to 24. We now increment I, and we're going to say result at I equals right at I, which is 12, times left at I, which is 1. 1 times 12 is 12. So we update result at I to be 12. And now we are going to increment I yet again. And we have result at I equals result, or right at I should say, of 4 times left at I of 2. And that 4 times 2 is 8. So I'm going to update result at I to be 8. And then finally, we have result at I equals right at I, which is 1, times left at I, which is 6. And we know that to be 6. So that's pretty much the problem. We're just getting the product of every number to the left of that specific index, and then every number to the right of that specific index, and then we can make a result array in the end, and then just multiply those two together, and then update the specific index with that answer. And that's an easy way to solve this problem. Let's hop over to the code editor, and I'll show you how to write this up. Okay, so here we are, the code editor. You can see I've made a function called product accept self, and it's just taking the nums we're passing in here. Let's return those nums to make sure it's firing correctly. Let's run this code. Okay, looks good. All right, so just like before in the explanation, we first want to make a left and a right. So I'm going to say left equals array, and then we're going to pass in the length, new array, sorry. I'm going to pass in the length of nums. And we can fill that array with 1, okay? Same thing for the right, just like that. And I'm actually going to do this also for the result array, because the result array doesn't matter what we put in there because we're going to update it anyways. Okay, so let's make sure that looks good. Run the code. All right, we're making arrays, cool. So for the first one, we want to get the products of everything to the left of the current element. We're going to make a for loop, initialize I to 1, and then we're going to loop over the entirety of nums. Okay. And basically, we need to update left at I. So we're going to say left at I equals left at I minus 1 times nums at I minus 1, right? Because that's going to give us the product of everything to the left of the current element at I. So if I was to return, let's return nums. You can see what nums looks like. And then now let's return left. And now you can see at that specific index, you have the accurate product to the left. So if I was at right here, this should be a 6 because 1 times 2 times 3 is 6. If I was at this index, I should get a 2 because 1 times 2 is 2, and I do have a 2. If I was at this index, I should just get 1 because 1 times 1 is 1. You get the idea. All right, so now we need to do the same thing for the right-hand side. Recall that it's a little bit inverse because we are starting at the second to last element. So I'm going to set I equal to nums.length minus 2. This is going to give us the second to last element here. And then while I is greater than or equal to 0, I'm going to decrement I. And just the same concept as before, right at I equals right at I plus 1 times nums at I plus 1. Let's clear this, and I'm going to return nums, and then I'm going to return right, And you can see now, do I have everything to the right of that number at that specific index? So when I'm at this index, well, there's nothing to the right of that, so it should just be a 1. It is. When I'm at this index, you have just a 4 to the right of it, so it should be a 4, which it is. At this index, I only have 3 times 4, which is 12, so this should be a 12. It is. And then finally, at this index when I equals 0, you have 2 times 3 times 4, which is 24. So it looks like my left and right arrays have the appropriate values in them. Now we just need to update our result array to return the answer. So let's do that now. I'm just going to loop through the length of the result array started from index 0. And I'm just going to update result at index I, just like in the explanation, to be left at I times right at I. And we can just return that result. And let's see. Yeah, and that looks good. So there you have it. Let's actually plug it into Leetcode. All right, we're in Leetcode, and I'm just going to copy and paste the solution, see how fast it is or how slow it is. And it looks pretty good. So if you enjoyed this video, make sure to like and subscribe, and I will see you in the next one.